Hey nerds, Todd Simmons coming back at you with some more Toddomation. I want to continue in this video with the series that I have on the Cisco 9800 wireless controller, and then of course using Python and Netmiko to automate certain tasks. One of the tasks that I get often asked about is the AP connectivity rates to the switches. So yes, you can see that in the controller. And more specifically, we want to look at how fast or how slow they're connected. Now, you should have an expected connectivity rate for those APs on the switch, and they will report that to the controller. For this video, I'm going to use the expected connectivity rate is anything that's 1 gig or higher. So we're going to search for APs that are not connected at 1 gig. If you have APs that are connecting, at 100 meg or 10 meg, that probably tells you have some cabling problems, or you have a bad Ethernet adapter on the AP, or quite frankly, the switch might have a bad port on it. So that's what we're going to look for today. The AP Ethernet speeds as the APs are connected to the controller. So what do you need? I'm going to be using VS Code, but you have to have some type of integrated development environment. You have to install Netmiko. If you haven't installed Netmiko or have never used Netmiko, jump on over to the video that I'm going to bookmark in this video that shows you how to get the initial connectivity set up. We're going to use TextFSM. Once again, in the initial video that I did talking about how to connect to the controller, just looking at AP summary information, you can get that from that video that'll be bookmarked here. You'll need access to a controller, or you'll need the files that we would get from the controller, which I am going to provide to you in my GitHub, along with the code that I'm using here in my GitHub repo. And this is for the new Cisco Catalyst line, the 9800s, not the older AROS, 5520, 3504, 8540, or even something really old like a 2504 or a 5508. So this is specifically for the new iOS. The command, we're going to run a command against the controller, and that command will output a ton of information depending on the number of APs that you have. So the one that I'm going to show you has well over 1,000 APs, and that's when it's difficult to go through and being able to just look as a human and say, oh, that AP is not connected at a gig. The command that we're going to use is this command right here, the show AP Ethernet statistics. Now that will grab everything from the controller. So it's not going to go through and just look at each individual AP. It's going to take that information and then it's going to output it. So we're going to use Netmiko to take that output and then to get the output, I should say, and then we're going to write that to a file so we can parse it better. Once we have that in a text file, we can open that text file and bring it in as a list using read lines. I'm going to use the TextFSM template. I'm going to write the template, which again, I'll provide that specific template to you inside my GitHub repo. But we're going to use TextFSM to read that information and then create dictionaries based on regular expressions inside there. I'm also going to give you an option to take that information and write it to a JSON data file, just in case you're like, what, can I just get that information in a JSON and not just have it in the text? Yes, you can. I'm going to show you how to do that. And then lastly, I wrote a method, a very simple method that's just going to go through that dictionary that TextFSM is going to give to us. We're going to glean the data just a little bit and just grab what we want. But then we're going to send that to a method that I write called apEthernet that's going to come back and return us only the APs that have a connection that's less than 1 gig. So first of all, the FSM template that we're going to use, just to talk about FSM here real quick, it uses these values, and those values are going to be variables, and it's all based on regular expressions. So when you have APs, it's kind of a critical part on how you name them. So you're going to have a regular expression that you're going to be able to pull out that's going to allow you to search for those AP names. So the APs that I'm using today, they'll all start with the name or the letters A and P and then a dash. So if you look at my regular expression on the screen, you'll see that it's just AP dash A /W just means any word character, so it can be a number or a letter. 3 of those, followed by a dash, followed by 8 more entries. So I like to use all 15 characters when I name an AP. If you're wondering why you have up to 15 characters, when you're using programs like Ekahau or AirMagnet or NetAlly, the information element associated with the AP name that's in the beacon can be up to 15 characters. So I like to use all 15 characters because it makes it just a lot easier for me to go back and do searches, since I know that each AP is going to have 15 characters in its name. We're also going to grab the interface information. This is for a Cisco AP, since of course we're on the 9800, and it's from interface Gigabit Ethernet 0. Then we're going to look at the status. The status has 2 options, either up or down. Then we'll have the value for speed. The speed is going to tell us what it's connected at. And then of course the duplex. Value that we get from there. This is the TextFSM template. Those were the values that we're going to use. After the start, that's just how the template is going to actually parse the data as it comes in. Don't want to spend a bunch of time on the FSM template. I just want to make sure that you have a basic understanding of what those values are. Okay, that's it for the PowerPoint piece of it. So let's just go ahead and move over into the code itself. The first thing that we're going to do is we're going to need to actually get the information from the controller, and I wrote this get ethernet.py Python file. Very, very simple here. The file name is going to be the file that gets created after I run this command. And you're like, well, what's the start? Well, I'm using a start here and an end here because depending on how many APs you have is really going to depend on how long this process is going to take. And by default, when we use Netmiko, after 6 seconds, Netmiko is going to time out and say, okay, that was, I ran your command, but I never got anything back, or the command didn't finish running, and we're going to get an error out of Netmiko. So we like to know how long the process is going to take. So initially, I put those start and end timers in there just to be able to show me how long something takes. So once again, if you have not gone through the initial video on how to set up Netmiko, go ahead and jump into that video real quick. So here's the device information that I'm going to use to connect. This net connect is actually what's going to connect me to Netmiko using the connect handler. Once it actually connects, that's when I'm going to start my timer. I'm going to run a command, and config is going to be the variable for that output. The command is going to be netconnect.send command. That's going to send the single command. Then the command is show AP Ethernet statistics. Notice I did a read timeout of 30. That means that I will wait up to 30 seconds for this timeout before it errors based on timing out. It should not take that long with this command. Now, if you have 10,000 APs, 20,000 APs, it might. So you'll want to adjust this read timeout. But for the 1,200 APs that I have on this particular controller, 30 seconds is enough time. If you want to get that down even lower and be more accurate, now it's not going to wait the full 30 seconds. Once it gets the host name information back, Netmiko is really smart and it's going to finish it, the connection. Once that connection is done, I want to disconnect after it's ended. I'm then going to take that file name that I created up here, this AP Ethernet stats.txt. I'm going to open that file. I'm going to set it as using the as F, and then for each line in the config, which means each line that came back from the show AP Ethernet statistics information, I want to write that to that particular file. Okay, and then the end, after that's done writing, it would do the end, and then the total time is pretty simple. It's the end time minus the start time. So that's going to create this file here. Now you can see mine is very, very long. If we look into it, the file length is going to be well over 6,000 lines just because there's so many APs here. And this is the exact output of what we're going to get from the command, that statistics command that we're looking for, the Ethernet summary. It's going to show us for each AP, it's going to have the AP name at the top, hence our TextFSM. So I know that all of this data from here over to here is going to be for this specific AP, or 0033, the last four of this particular one. Once we get this file, we're done with the get Ethernet portion of it. I'm going to go ahead and close that file out. I'm also going to close this AP Ethernet stats file out, because afterwards, once we get this, I should say, we're going to run this through TextFSM. Okay, so how do we do that? Well, we start with the AP Ethernet Python file that I wrote. I have defined a single method in here, which we will get to in a minute, but that's there at the top. We're going to have a couple of files that we're specifying. This out file is going to be a JSON. Remember, I told you that we can save that text data as JSON, going to be a lot cleaner than everything that you just saw on the screen. Of course, the input file is that same file that we just looked at, the AP Ethernet stats.txt file. Notice I've got some ETH headers that I'm going to be using. It's just a list of the headers. For a very, very long file, we're going to want to write this to a CSV using pandas. And then I've got an AP dict dictionary. It's empty right now, but I'm going to take that. I'm going to take specific information and write it to this dictionary. So just like we wrote to that particular file with this with open, we're now going to read from that particular file. I'm then going to open my template. I'm going to show you the template. Once again, this is on my in my Git, but this is the template. It's exactly what we look like in that PowerPoint. There's no difference. Here are the values that it's looking for. Once we start it, it's going to start. The first thing it's going to do is look for that AP name. Then it's going to look for the interface, the speed, and the duplex. Right? This is just standard TextFSM stuff as we're going to go through it, looking for any characters and any end-of-line characters. Once we're done, we're going to name this each individual's AP name, and then interface, status, speed, and duplex, just like we have collected. It's going to run through that for every single line until it gets to the end of the almost 7,000 line file that we just looked at. And it's going to return a data structure. So that data structure is going to be FSM results. Here was the template that we opened. Okay. The RE_table is then going to take that using TextFSM in the template information that we have here that we opened, and it's going to return RE table. We're then going to have our FSM results are going to be the parsed text, and we're going to call it raw text data. Okay. The raw text data, of course, is the input file from the text file that we ran. And that's going to give us FSM results that's going to be a dictionary. Okay. After that, we want to look in that dictionary because I'm only interested in a couple of things to make a determination if an AP is not connected at a gig or not. So I'm going to use this new dictionary that we created up top that was originally empty called AP_dict. I'm going to create a temp dictionary to put in this dictionary. So yes, we're going to have a dictionary of dictionaries as far as the file. What I'm looking for is the AP name, and then its status, speed, and duplex, and I'm going to write that to this AP dict. If you ask yourself, well, why take a dictionary, write it to a dictionary? There's information that I may or may not want at a later date inside the way that I wrote the TextFSM. But to determine just speed, I don't need everything. So I'm putting it into a dictionary into a way that's a little easier for me to parse through that data. So next, you'll see that this is commented. So I'm going to go ahead and uncomment this just to show it to you. And what I'm going to do is with open out file, and out file is the name of the JSON file. And I'm going to dump that, the data that I got from apdict, which is what I wrote using this for loop up here, and doing an indent. That's going to give me a JSON file specific to this data here, which if you look at it, you're like, man, I've got so many in here. Let me just save it as a JSON file. That way I don't have to keep going back to that text file. That's why you would want to create it. We want to write it as a JSON file. Also, if you write it as a JSON, you don't want to keep going back to that text file. You can use these commands here, which is going to open that out file or that JSON file and then call it ETH data. Okay. You have an option once we get to this point. I'm going to show you just using the apdict information here, not using the ETH data. But if you were using the JSON information, you could comment out everything that you have before this point. All of this could be commented out. So you could just use the JSON data. I am not going to do that. I am going to write the JSON file so you can see it, so I'm going to leave that piece uncommented, but I am not going to open the JSON file and then send that to the method that I wrote above this, the apEthernet method. If you did, you would actually want to use this call instead of the call that I'm going to use. Looks like there's already a file in here. Let's just delete this file real quick. The file that I'm deleting is the CSV. So lastly, if you want to write all of this information to a CSV, which I recommend, you can print it if you want to the screen, but if you've got 200 of them or even 20 of them, it becomes a lot on the screen. It's easier just to have a file that's going to show you how to do that. So using pandas and of course just the standard DF, we're going to take that information, which is the results, which is what we're going to get from the apEthernet method that I wrote up there. The columns is going to be based on the ETH headers. We saw that before. I created those headers showing the information that we want written to the CSV. And then, of course, this just writes it to the CSV. The name of the CSV, I didn't create a variable name for it, is APs with Ethernet issue.csv. We're going to use mode W to write. We're not going to index it. We're going to use the headers that I've specified. And the separator that we're going to use for a CSV, pretty common, is a comma. And then at the end, we're just going to p-print the results to show you what it looks like. So let's look at this apEthernet method that I wrote just real fast. Here it is. Here's the apEthernet. As you can see, we're going to expect data. That's actually going to be a dictionary that we're going to come in. I'm going to create a list of results that I'm going to return. As you can see here, I'm returning this list. So I'm going to take this information and add it to that list. So actually, I'm going to return a list of lists when you go through this. So for AP and apconfig and data.items, that tells you we're getting a dictionary because we're using the items method to expand the dictionary. I want the ETH speed to be listed as apconfig speed, but then I want to go just a little bit further and look at the speed because using the regular expressions find all, I want to specify that we're looking for only digits, so I don't want the M's or the G's or anything else that's in there from this ETH speed. And then I've got a final variable that's just going to give me an integer representation of whatever speed was found. So we know speed's already in there because it was in the text file. So we're sending through that ETH speed. After that, I'm going to assign a variable of duplex to whatever the duplex was, the value in duplex, and then with that AP list that I have here, once again, remember I said we're going to do a list of lists. I'm going to take a look at what the ETH speed actually came up to be. If it's less than that integer of 1,000, it's then going to add the AP name, the ETH speed, and the duplex into a list. So that list is going to have 3 entries. And then I'm going to append that list to my main list that I've created here. So this list gets appended to the results list, which is going to be part of it. So here's my list of lists. So every time it goes through here, every AP that it finds whose Ethernet speed does not match 1,000, it's going to collect the AP name, the actual speed, and the duplex that it's running at, and it's going to add it to this. It's going to append that list to this list. Okay, and then it's going to return those results. And then the results here are what I'm going to write to my CSV here. And that's it. So since I already have those files, I went and did the get Ethernet already. So I already have my apEthernet stat, so I can show you here. So let's just jump into apEthernet here. So when I run this particular code, it's going to take all of that information, run it through TextFSM, create my JSON file, and then it's going to also create my CSV. Should be pretty quick. It's 1,200 APs, but we go really fast. So let's just go ahead and run it, and there it is. So here are all the APs that it found. Once again, as you can see, it's a list of lists. And then it's got the name of the AP and its current speed, and then it's duplex. So this was just the preprint to the screen. Let's make sure that we got everything that we expected. The first thing we expected is this out file. Now this out file, remember, was not filtered. You can see that we have an AP Ethernet JSON. So here is every single access point. This is going to be a long file because there was well over 1,200 access points here. So it's going to be almost 6,000 lines of JSON showing the AP name, its status, its speed, and its duplex. So that was the JSON file that we wrote that you can read from if you would like. And then the CSV is just going to be an output of the specific issues or APs that weren't connected. So as you can see, we've got, 17 access points. Here are the names of the access points. Looks like they're all at 1 meg with full duplex. Now, this tells us one of two things. It's an AP. The AP should not be connected 100 meg, which means that we either have a bad cable, which is most likely, so run a TDR test on that thing, or we have a bad port on either the AP or the switch. But here's the information that we were looking for, along with a little more. Now remember, if you do want to run this JSON file as before, just to show you, I'm going to go ahead and close this CSV. I'm going to delete this CSV file. I'm going to go ahead and tell this JSON file to now be opened. And then I'm going to use the ETH data here. So I'm going to uncomment this line. Okay. So there's no need for me to go in and get anything else because I already have that file. So I can comment out pretty much everything that we had before. I don't need to run any of my template data. Okay. I don't need to open the input file. So I'm just going to comment all this out. What I do need is I do have to have this AP Ethernet. The out file, the input file, I'm going to leave those there just because they are being used when I call. So now what I'm going to do is just open the out file. Actually, I do not need this one because we've already wrote it. So now I'm just going to open the out file as ETH data. And with ETH data, I'm going to run it. So I should get the CSV again here. Let's run it. And it printed it out, and there we go. So now I've got the CSV file, and I was able to get the same information because I took the information that I used TextFSM to glean from the text file, from the output of the controller, and now I actually have the data. So if you had a lot of issues and wanted to use the JSON, I did want to show you that way to do it. Again, if you're using the pprint, you don't have to use the pprint just because it's going to, if there's a lot of data, it would show it to you. So we'll remove that and run it again. And we still have the same information here. Well, that's it for looking at the connectivity speeds of an access point connected to a Cisco 9800 controller. If you have any requests, put it in the comments below. And as always, please like the video if you got something from it. Subscribe would be great. I would really appreciate that. But until next time, talk to y'all later, nerds. Bye.